Hi and Assalamualaikum. My name is Siti Nursyakinah Maisarah Binti Abdullah. My mentor number is BE32402. So for this group project, which is numerical method, we will discuss about approximation monthly of electricity consumption. So this is our group member. First group member is Ardiny Hamidah. Second is Nawwal Binti Mohd Radhi. And me, which is Siti Nursyakinah Maisarah Binti Abdullah, and last our group member is Ummi Raihanah Binti Roslee. So for introduction, which is project background, we apply our knowledge about Lagrange interpolation and Newton division difference method to create a mathematical relationship between electric usage and temperature. Next is to determine the temperature using data from the internet that we have collected on the monthly energy usage of villa near the airport. To determine the temperature in April that correspond to a given amount of electric consumption, we use the Lagrange interpolation with Newton divided difference method. And last, we need to solve this problem. We use the software MATLAB to stimulate this project. Beside the data is taken from Applied Energy Journal, which is published by Elsevier. Next is for problem statement. So for the table 1.0, which is monthly normalized electricity consumption for villas in the airport area, which we can see in the table we have interval 0, 1, 2, 3, 4 and electricity consumption in kilowatt per meter, which is 3, 6, 8, 10 and 11, and the temperature 18.4, 30.9, 33.7, 34.1 and 35.5. And the next figure is graph for electricity consumption for villas in the airport area. So our question we need to solve is approximate F4 by using Lagrange interpolation and Newton's divided difference method.
Hi, Assalamualaikum. My name is Ardiny Hamidah. My 0105. Next, I will continue to the next part, which is methodology. Based on electricity consumption for villas in the airport area, we are using two methods to solve this problem. The method is from chapter 3, which is interpolation. First method, Lagrange interpolation, polynomial of degree. There are 4 approximations we are using in this problem. The first one is linear, quadratic, cubic and quartic. Let's move to the first approximation. These are the formula for the linear approximation. They are using only 2 points. Okay. So the formula is 4. 4 is the value of electricity power consumption that we want to find the temperature minus the value in the table over 3, which is the value of the electricity consumption, times 18.4, the temperature when the electricity consumption is 3, plus the value of 4 that we want to find the temperature, minus 3 over 6 minus 3 times the temperature, and then we sum the value, we get the answer. So here the simulation in MATLAB, and then we get this answer 22.5667. Next is quadratic approximation. The method is same, okay, but the difference only the point. There are 3 points in quadratic approximation from iteration 0 to 2. Okay, so these are the simulation and we get this answer 23.6733 degrees Celsius. Next is cubic approximation. Okay. There are 4 points given when we want to find using cubic approximation. So this is the formula. Okay. And we get 23.9629 degrees Celsius. So this one is our simulation to find cubic approximation. Lastly is quartic approximation. This one is the whole table, and then we so this is the formula, and then we sum up, we get 23.50 degree Celsius. This is our simulation in MATLAB. That's all from me. Thank you. I will continue to the next part, which is the project simulation using MATLAB. The first line is our electricity consumption in kilowatt-hour per meter square. We are using the first approximation, which is linear. There will be 2 points given. First one is 3 kilowatt-hour per meter square, and the temperature is 18.4 degrees Celsius. And 6 kilowatt-hour per meter square, the temperature is 30.9 degrees Celsius. And is we define our iteration xp equal to 4. This is we want to find the temperature when the electricity consumption is equal to 4. And then we initialize our sum value equal to 0. Next, we define the first loop, which is I equal to 1. The value of I will always increase as the increasing the looping. The product variable defined equal to 1. Okay, next we define the for loop for j equal to 1. The j loop also increase as the increase in the looping. J value cannot equal to 1. And then we compute this equation in J loop. PR, which is the product, equal to PR times XP minus XJ over XI minus XJ. And then we compute the second equation, compute sum within I loop. So sum equal to sum plus YI times PR. And then after finish the looping, we will get the temperature equal to sum. We run the simulation and we get 22.5667 degrees Celsius. Next method, we are doing the quadratic approximation. There will be 3 points, which is 8. When the electricity consumption is 8, the temperature will be 33.7 degrees Celsius. And we run the simulation, we get the answer 23.6733. Next is the third method, which is the third approximation, which is the cubic approximation. There will be 4 points given, and the additional point is for 10 electricity consumption, and the temperature is 34.1 degrees Celsius. We run the simulation, we get 23.9629 degrees Celsius. This approximation is quartic approximation. There will be 1, 2, 3, 4, 5 points, and the additional point is 11. When the electricity consumption is 11 kilowatt per meter square, the temperature will be 35.1 degrees Celsius. We run the simulation and we get 23.5 degrees Celsius.
Assalamualaikum and hi, my name is Ummi, Raihanah, Binti, Roslee, and my metric number is BEE32402. So I will present the part which is Newton's divided difference method that we use to find our issues. So the function of Newton's divided difference is quite same with Lagrange interpolation. However, more data or points can be added by using Newton's divided difference, while Lagrange is better to use when x is at one value. Divided difference method is more applicable to various problems and has better accuracy than Lagrange interpolation. So before that, let's see the data given. So our data is, we use the month from February until August. So we assume the temperature in March and April is unknown. So we want to find the electricity consumption, which is 4. Firstly, we create a table and put the data given from 3 until 11 and 18.4 until 35.1. So we use the formula to find the value and then insert in the table. After that, we want to find the unknown, so F4, and we use the first arrow in iteration 0 to get the temperature. So the temperature that we get is 23.5021. This is the MATLAB coding. that we use. So the answer is 23.5. So let's see how the coding ran in MATLAB software.
Okay, so this is the coding in MATLAB. So we insert the data given. So from 3 until 11. For the temperature, we from 18.4 until 35.1. Put for the unknown that we want to find. Then we click run to see the answer. So the answer is 23.5, same as the handwritten.
Assalamualaikum. Hi, my name is Nawwal Binti Radhi with the number metric 1007. Today I will explain our result and discussion. So in general, in solving engineering problem, we can use Lagrange interpolation and Newton divided differences. Lagrange interpolation enable us to find the value of a function at a specific point within the range of known data points. It helps to fill in the gaps between the data points and provide an estimate of the function behavior at intermediate locations. And similar to the Lagrange interpolation, Newton divided differences can interpolate the value of a function at a specific point within the range of known data points. And by using these methods, we can solve both linear and quadratic interpolation to calculate the approximate temperature based on the electric consumption. So let's start with the Lagrange interpolation. So we did use the linear approximation, quadratic approximation, and cubic approximation. Hence, this method produces relatively the same result in MATLAB simulation and manual calculation. The value of temperature is in the range of 22.6 to 24, which is consistent with the result obtained in MATLAB simulation. Next, for Newton divided difference, the method creates a polynomial that passes through the data points using divided differences. And the result polynomial guarantees that it matches the y value of each data point when evaluated at its corresponding x value. And this method consistently produces the same result whether calculated manually or in MATLAB simulation. So moving to the results. So this is the result based on the simulations. With linear approximation, we get that the temperature is 22.567. Quadratic approximation is 23.6733. And for cubic approximation, we get that it's 23.5. And lastly, for the Newton divided difference, we also get 23.5. So moving to the manual calculation. For linear approximation, we do get the same for the manual calculation and the simulated in MATLAB. So which the answer is 22.5667. So for quadratic approximation, we get that the manual calculation is 23.6733 and also the same with the simulation in MATLAB. For cubic approximation, we do get the slightly different answer, which is the manual calculation is 23.9629 and in simulation we get 23.5. And lastly, for Newton divided difference, we get the manual calculation is 23.5021 and in the simulation is 23.5, which is quite the same value. So finally, the result obtained in both methods is relatively the same. We can confirm the calculated value is valid compared to the actual data based on the reference. The value might differ from the actual data due to the calculated value is only an approximate value. So I think that's it from me. Thank you.
So let's is our conclusion. So for the conclusion, we obtain the same result from the data sheet that we using the information from the data sheet, the calculation that we perform, and also the MATLAB simulating that we perform as well. This show how the two mathematical relationships allow us to accurately predict the amount of electricity used in the villa near the airport. So for overall, the research we conduct show how well Newton divided difference and Lagrange interpolation method to estimate the temperature from the data on electric usage. So that's all from us. Thank you for watching.